All right, we're going to look at some examples of what exactly literal equations are and how to solve them in terms of other variables. Okay. Now, first, we're going to start with the area formula for a circle, pi r squared. All right, it's really pi times r squared, or pi times, radius, if we will. But right now, notice that this equation is in terms of A, in terms of the area. Because typically in a circle, we want to know what the area is, so we set it equal to the formula, and we figure out what all this stuff is. Typically, we will plug a number in for the radius, and we'll get an actual number in the end that we know that the radius is equal to, some value. But a literal equation basically is taking an equation like this and rewriting it in terms of another variable. Instead of this being a in terms of r, maybe I want to solve for r in terms of a. Like, what if I knew what the area was for this circle, and I really want to know what the radius is? Well, if I had a nice formula that was radius equals, and then somewhere embedded in there was the area that I could just plug that number into, and then I could work it out and get my radius. So this is what we're going to do. We're going to solve for the radius. Okay? So first thing I want to do is get this term, really this radius squared term, all by itself right now. So the first thing I would do here, I'm going to give it some space, is I would want to get rid of anything that's attached to it, like the pi. Now the pi right now is being multiplied with r squared. So to undo the multiplication, we would need to divide both sides by pi. So it's gone over here. So at this point, I have area divided by pi, and I have no idea what that is. Those are not like terms, so it's got to stay that way, is equal to r squared. Now again, if I want to get just r by itself, how do I get rid of that squared term? Well, I would need to square root both sides, the whole fraction over here. So now my square root and my square cancel each other out. And can I square root an a or a pi not knowing what they really are? No. So your answer is the radius is equal to the square root of the whole fraction, area divided by pi. So if you knew that the area of a circle was, say, 100, well, now you can take 100, plug it into a, divide it by pi, and then take the square root of that ugly, nasty thing, and that's what your radius of your circle would end up being. Okay, so again, we just took area equals pi r squared. We took a that's written in terms of r, and we've rewritten it so that we have r now in terms of a. So that's one example. Let's move on to a science example. Einstein's theory of relativity, the E equals mc squared. Okay, right now this is in terms of E. It's solved in E in terms of m and c. Now we have two variables. All right. So now let's say, what if I wanted to solve for and let's do two examples with this. Let's solve for m. Okay, so let's get m all by itself first. All right, if I want to solve for m, that means I need to get rid of this c squared. And right now, c squared is implying here that it is being multiplied with m. So I would need to divide the c squared over. So now I have m equals e divided by c squared. And I'm done. Look, I've got m equals. That's the main thing. So m equals whatever e is divided by c squared. So there's solving for m. I solve for m now in terms of e and c. Now let's take the same beginning point, e equals mc squared, and now let's solve for c. So this is going to look very similar to our area equals pi r squared example. So if I want to solve for c, first I need to get rid of the m. I would divide it over, cancels. And so now, get rid of that. Now I've just got c squared equals e divided by m. But I want to get c all by itself. So I need to square root both sides, the entire fraction, and the square and square root knock each other out. So c is equal to the square root of e divided by m. And so now I have solved for c in terms of e and m. One more example, and hopefully you are not a casualty of this example. We have e to the p plus I minus c equals the square root of f plus a I l. Okay, this is really a times I times l, if you will. Now, I've got lots of options to solve for. There's really nothing this is already solved in terms of, right? This isn't just c equals something, or I equals something, or f equals something. This is just a random looking equation here. But let's solve for, f. So this is the thing I want to get all by itself. Okay, so first thing, I can't really subtract this AIL term because it's all underneath the square root. So first I need to get rid of the square root. And to get rid of a square root, I would need to square all of that, which means I also need to come over here and square all of that side. So on the right side, the big square root and the square cancel each other out, and everything that's left underneath, my f plus a times I times l, is left there. And you can do whatever you want with this, but I would highly recommend just leaving it as e to the p plus I minus c quantity squared. Just leave it at that, okay? Again, I'm looking to get this f all by itself. So now this is one term, AIL, a times I times l, and it is being added to f. So I just need to subtract the AIL term. So now I have f equals e to the p plus I minus c, all of that squared, minus really a times I times l. And there's my equation of f in terms of all of these other variables. So that's one example. Okay, so let's try another one real quick here. Let's pick another variable to solve for. Let's see if I can remember what all that was now. We had e to the p plus I minus c equals the square root of f plus AIL. Okay, let's pick something else that's not going to be too terribly crazy tricky to solve for. Let's do c. Let's solve for c. Let's get c all by itself. All right, so c is on the left side. We need to get rid of these other things over here. So, let's subtract an I over. So we subtract that over. So I still have e to the p minus c. Now, I can't really subtract this and the I because they're not like terms. Now, granted, there is an I underneath that square root, but it would have to be pretty much the only thing underneath there to be able to do. So I just rewrite this as the square root of fail, if you will, minus the I. Okay, I can't do anything with that. It's got to stay that way. Now I need to get rid of this e to the p. Now e to the p is being, addition subtraction here with my c term. So it's a positive e to the p, so I just need to subtract it over. So that crosses out, and now I'm left with negative c equals, and I'm going to do the same thing like I did with the last one. There was my minus I subtracted over. Now I'm going to subtract over an e to the p. There's no like terms here, so it all just stays like this. Now I'm almost done, except I have a negative c. Now think about this. This is really a negative 1. So I could divide everything by negative 1. Okay. Now what that really does, ultimately, is it's just going to change my signs everywhere. So I can say, all right, let's make that positive. This is now a minus a square root. This is now going to be a plus I, and this will now be a plus e to the p. So really c equals the negative square root of f plus a times I times l plus I plus e to the p. And that would be our answer if I wanted to solve for c. Now, solving for p originally, or solving for some other things in here might be a little bit more tricky. Like if I wanted to solve for I, and I is in 2 places, that can be a little hairy. So we're just going to stick with easier examples for now. All right, so those are the main examples I wanted you guys to see. And now try your best to see if you can figure out how to solve the rest of your literal equations. Good luck. All right, let's throw one more example into the video here. Now, if I want to solve for P, one thing I want you to notice immediately is that P is located in multiple places in here. All right. Now, your goal, if you have multiple versions of what you want to solve for in your equation, that it's in more than one term, right? Because these are two different terms here, separated by our plus sign. You want to first get these things on the same side of the equation, either the left or the right, but nothing else that's like it. So the first thing I want to have to do here is I need to get rid of this plus 7 because it doesn't have a p in it. So I'm going to subtract it over. So it's gone. So I'm left with my 3p plus a times b times p equals, and then I can't combine this, so it stays 24k minus 7. Now that I've isolated the p so that only p terms are left on the left side here, what I want to do, bring that back, there we go. What I wanted to do is to pull out the p from all of these terms here. Now, if I had another term that had a p, I would also have to pull the p out of it. So basically, I'm undistributing the p. So I'm factoring it out. So if I were to factor out a p from 3p, what would be left over? A 3. Plus, if I factored out a p from a times b times p, I would have a times b still left over. Okay, so I just undistributed what I did there. Now, it would make no sense for me to distribute it back because then I'd be right back where I was before. Now, this is technically p times all of this, 3 plus a times b. So if I want to solve for p, I now want to get rid of this whole quantity. So I want to undo the multiplication. So I would divide 3 plus ab over to the other side. So that's gone, and now I would have p equals 24k minus 7, all divided by 3 plus ab, or a times b. Now, you might ask, can I simplify anything? Can I simplify the 24 and 3 here and say that's 8? And the quick answer would be no. I've got junk in both trunks, in the numerator and denominator. Nothing in this mess here can simplify at all. So that would be my final answer for P. So again, if you have multiple terms, you need to get them all on the same side, flush everything else over to the other side, factor out what you want, and then flush out what is not a part of that P, what was left over from the factoring, divided over in this case.